Okay, I think we can. Start. So my hope is to take less than the time I have, less than the 4 to 5 minutes I have, and maybe get some questions later, or just gain some time for lunch. So I'll try to go through my slides. Well, not quickly, but I won't dwell too much on them. I'll try to give you some kind of, well, from my point of view, some perspective on how QuantLib is doing, how the people working on it, and whatever. I won't go much into new features in the library, into details. It will be more like the community and some kind of bird's eye view of the thing. So I'll start with just my personal feeling on how the thing is doing, and my personal feeling is we're doing fine. We're doing fine. This is based on the amount of admin work I'm doing in the library, on the amount of participation I see. Then again, well, it's my personal feeling, and since it's not much of a statistics, since I've been involved in just one niche open source project. Since this is just a feeling, I thought I'll go for a few figures, which are nowadays are easy enough to get by. If you look at Git history and the figures on GitHub and so on. And well, I looked at the last last 4 years. So that makes for 8 releases, and doesn't look bad to me. I mean, we had around 60 contributors total. Per each release, we have something between 12 and 20 contributors. This means there is a nice mix of regular contributors, people that contribute to each release, sometimes that contributes a lot to each release, and occasional contributors. You can see it you can see there's a long tail in there. So the median contribution is 4 commits. 4 commits might as well be just one pull request, right? So one does a pull request, there is some exchange, something to change, something to fix. Those 4 commits might be one pull request. So the mode is just 1 commit. So people that fix something, contributes it, and then is not heard from for again, or well, maybe in the future. So well, I think it's a nice mix of contributors, and looking at the number of commits and the development of the code, we have something like well, almost 2,000 commits, not counting the merge commits. That means well, it's more than 1 commit per day on average. It's something like 9 commits per week. And the pull requests are 2.5 per week, or about 10 per month. Which, again, is not bad for a project which is, I mean, it's not an editor. It's not something which is widely used across users. And, well, also during this releases about 100,000 lines of code added, which is about 20% of the current size of the library. 50K changed, well, about half of the files were touched. And so, well, looks like it's actively developed. And well, one way to get a visual feeling for how much this is work done might be another kind of visualization. Well, you might have seen this before. I have made a video of this and put it on YouTube. But there is a tool out there. It's called Gauss or Gauss. I'm not sure how you pronounce that. Well, basically, it can read your version control history and visualize it as well. Let's see how that is. Okay, so this was the beginning of QuantLib. Basically, you see the little people going around. It's us touching files. Well, the branches and the dots are dots are files. The branches are directories. You can see who is touching what files. Well, it's kind of mesmerizing. You can. Well, I'm not going to show you the whole thing. I'm just going to point out a few phases in the thing. This was the start. So we started moving things, moving things around, breaking. Well, you see a big directory just disappearing and going somewhere else. So this is the beginning. We were finding our footing here. Well, if we go later, okay, you can see the date at the top. After a while, the thing stabilizes a bit. So okay, at this point we start having not so many people going around. It was me, Ferdinando, some contributors, but well, not a lot of them. So and this was also due to the well, mostly to the version control system we had in place at the time. So it was, I think it was still CVS at this time. So you had to be authorized as an official part of the group to contribute. Otherwise, you would send your patches and we would integrate into it. So, well, you see, just a few people going on. Later, well, we had some period in which there was, I think it's coming up, at some point a group in a bank started working on QuantLib. That was when we developed the market model inside QuantLib. That was done inside of okay, here the group comes. So here is where that group started working actively on QuantLib to develop the market model. This also gave me an opportunity to remember Mark Joshi, who led the effort and the group at the time. So lots of work here, and then again that stopped, and well, the development is slower now, and well, we can see at this point there's just a few people going around. This is just we had switched to Subversion. Again, you had to be authorized to contribute to contribute to the repo. So it was kind of cumbersome to do so. In June 2013, we switched to Git, and not only to Git, also to GitHub. That means contributed version control system. That means you can fork your copy of the repo, work on it, commit, and then just send us pull request. And well, you can see the effect right there. So you get more people starting to show up, new names, and they start buzzing around for a while, and then they disappear, and new people come in. If you look at well, basically any point in time, you see a nice cloud of people working on the library, appearing, disappearing. So visually, you can see how this move to Git helped increase commitment with the library and the contribution. So I think it's we are doing fine in this respect. I mean, there's some buzzing in there, and looks nice to me. Okay, one final statistic. We have about 60 posts per month on QuantLib User. Again, I have no idea what the number should be, because what's the number for a successful project with our number of users? I don't know. Anyway, here you go. I've talked about contribution to code. Also, we had some improvement in the infrastructure of the. I mentioned the switch to GitHub, which made it much easier to contribute. Also, in the past few months, we had a few improvements in the building and testing infrastructure, meaning that we started adding a few integrations to GitHub. You might have, if you have contributed a pull request, you might have noticed recently, you might have noticed that there are a few checks now done on it. So for instance, for each pull request and also each push to master, so each merge of a pull request, we have an integration with Travis CI, which is a continuous integration tool. It checks out the pull request or the repository, tries to merge with master, runs the part, builds it, runs part of the test suite on a number of configurations. We have, well, it works on Linux at this time, so we have GCC 4, 5, 6, and 7 currently, depending on what versions of Linux we use. Most of them use the latest Boost version. We also have one which uses an older one for regression testing. The build runs with high warning level and also stopping for any warning as an error, so it helps keeping the code clean, so the code has to compile without warnings and so on. I'm also trying to extend the build matrix so that it checks other non-standard configurations like intraday implementation for dates or indexed coupon as opposed to par coupons or a few others. But that's kind of a work in progress. We have other integrations. One is some kind of static analysis tool that helps improve the quality of the code. Lately, I'm talking about last week, I added one that checks that contributors to whoever contributes the pull request has signed some kind of agreement that says, yes, my employer knows what I'm doing, I'm allowed to contribute this, or this is my code I can contribute. And we also have a coverage tool that, well, this doesn't run all the time. I run it every once in a while to see if the coverage is on the whole improving or going worse. So we are at about, well, slightly more than 70% for the library, which is not bad. We have a 90% for the test suite, which is kind of puzzling if you think about it. It means that 90% of the test suite doesn't run during the test suite, which is kind of puzzling the type. But then I thought, no, we have a lot of construct like if this construction is not, if this condition is not true, then raise the error. The raise the error part is never exercised, so that might be the reason for that. Well, I'll have to investigate about this. Well, the long and short of it is we are adding stuff to the infrastructure. In short, the library seems to be actively worked on, so there are contributors, there are improvements. But, well, there's an interesting question I got asked from my former head of development, well, maybe, when was it? 2-3 years ago. In fact, it's not the first time I mentioned this. I think Peter heard me at the Fixed Income Conference. Well, the question was, well, he looked at me and said, Luigi, I have a question. Do you think, well, is QuantLib legacy code? Well, of course, I strenuously defended QuantLib. I looked him in the eye and said, well, maybe, which might not be bad. There are lots of definitions of legacy code. for instance, this Michael Feathers is the author of a book which is widely used. I think it's working effectively with legacy code. So what to do when you have this big mass of code and you have to enter and change it and working with it. According to his definition, legacy code is a code that has not enough tests, so you're afraid to change it because it might break if you change something. By this definition, we're not doing, well, not everybody agrees to this definition, especially those that don't write tests don't agree with the definition. But anyway, according to this one, we're not doing that bad. We are at 70% coverage. There are some parts of the code that are not that covered that much, so it's true in part. But anyway, this is one way to look at it. And again, then other people say, well, legacy code means that, it's a successful code because it survived long enough and it got used from enough people that you have to maintain it and you have to go in and still make changes to it. And well, that's not bad either, but well, it's not easy to define what legacy code is. Usually those questions end up closed on Stack Overflow. They say, what does it mean legacy code? Closed, opinion-based, not a question for Stack Overflow. But well, I'll look at a few. I'll look at QuantLib in a few ways, and because well, this still gives us some food for thought. So, for instance, we are having the 5th anniversary. Those of you who were here for the first user meeting might remember this slide. It's from the talk I had at that meeting. It's on, well, you can look for it. It's on YouTube. Don't write down this code. You can just look for Luigi Ballabio, QuantLib User Meeting, or whatever. And that was the architecture of the library. It's from 2004. In the talk, I talked about the limitations, some limitations of the architecture, the need of going forward in some way, but of the fact that we don't really know how at this time, and also, well, people might rely on this by, and well, this might be one way. It's legacy in the sense that the architecture is from almost 15 years ago now, 10, 15 years ago, let's say. It has limitations. We are aware of those. We'd like to change something and do better, but well, at this point, the architecture is still the same. There are still no plans to change architecture because I don't have a lot of ideas about how to change those shortcomings. On top of this, well, we don't have much time nobody's working full time of QuantLib, so no time, no budget. And also, I'm kind of afraid that we might go into the same kind of trouble the Python 3 migration had, which, well, nowadays Python 3 migration is succeeding. Well, for those of you who are not familiar with it, Python did in, well, I think 2008, they decided to change a major version, so Python 3, from Python 2.7 at the time. And the Python developers decided, okay, let's do a major version, and we are fixing a few things in Python. So a few inconsistencies in syntax, proper Unicode support. There were a number of things they wanted to fix. They did. And problem is, adoption for Python 3 in the beginning was close to zero. Most people kept working on Python 2. The writers of libraries and modules kept writing their modules for Python 2, and it took a huge amount of effort from the Python developers to get most people to start supporting Python 3 and switching to Python 3. Nowadays they are succeeding. Some modules are going to go, for instance, NumPy, which is a pretty big and pretty widely used module, is going to go Python 3 only in a couple of years. And so the transition is succeeding nowadays. But it took 9 years and a lot of effort from the Python developers. You'll notice from this slide that we don't have that kind of the resources to put in that kind of effort. So any kind of change in the libraries that forces people to switch from their code from one to the other and forces people to put work into that, well, I'm not sure it's going to succeed. This is also the reason why we are keeping backward compatibility since version 1.0. So we are not breaking we are not removing or changing any method which is working. The idea is if you have written code that calls into QuantLib and you upgrade your QuantLib version, your code should still compile and work, which well, means that we are not changing things at a big rate. Well, it's good. It's good because people's code rely on this, and one of the laws of software development is that you shouldn't break fiddle faddle that's working. Well, in the original version of the law, it wasn't fiddle faddle, but it wasn't family friendly, so I replaced that. And with thanks to David Walker for the replacement. So things shouldn't break when you upgrade your library. I've just in the past weeks or past couple of weeks, I just saw a number of tweets from Joe Armstrong. He's the inventor of Erlang, complaining because, well, I upgraded my iPhone system and now lots of apps are not working anymore. That's not the way to write software, and well, he went on about it for a while. So we're not changing a lot. What we're doing when we need we realize some interface is not entirely correct, is we make some kind of small steps. We use deprecation, which means we mark, well, we overload the method, so maybe we add another version, taking the required parameters, the new required parameters. We mark the old one as deprecated, so that if your code uses it, when you compile, you're going to get a warning that you're using a deprecated version, so you can look it up and upgrade. After a couple of releases, we remove the old version so that we don't have to maintain it any longer. This might be a bit fast. I should probably slow down and wait 1 year or so before, or 3-4 releases or whatever, before removing stuff. This said, some of you might be thinking that I'm going on about deprecation and architecture and whatever, where there is there might be some other things to address, like, okay, Luigi, you're talking of legacy might mean this or that, but are you ever going to mention during this talk that, well, the worlds keep turning and new stuff happens, like recently C++ 17 has been approved and we're still at C++ 03. Well, yeah, that's this might be another definition of legacy code, one which developers often use, which means we are stuck using old tech. There is a cool new tech that we want to try and play with, and so the old one is a legacy in a pejorative sense. Well, yeah, we are still guilty as charged. We are still a C++ 03. We are still supporting compilers like Visual Studio 9 that Microsoft itself is about to stop supporting in a few months. But well, this turned out to be useful actually sometimes because people still had old compilers. Well, there is some good news, like Microsoft, for instance. As you see, Microsoft is going to stop supporting Visual 2009 in April. We are going to do so as well, so we can remove that part of support. So we can go on, right? Not really, because, well, there are a few things working against upgrading the language. One, I mentioned Python before. QuantLib also is exported to Python, and it actually seems to be becoming an important part of the ecosystem. From the number of questions I get on the mailing list on Stack Overflow, there are quite a few people using QuantLib from Python. Well, I'm even writing a book about it, and one of the problems is with an upgrade is Visual 9 is still the compiler which is required for Python 2.7. Well, in turn, Python 2.7, of course, is deprecated. Is going to the Python team is going to stop supporting. Well, not so soon, in 2020, I think. But well, people is switching to Python 3, as I said. From an informal poll on Twitter, about 80% of the people who answered was on Python 3, 3.5 actually, and just 20% of Python 2, which is, well, still not a big slice, but well, a decent slice of the pie. So, well, we'll see if we can drop Python 2 at some time and so go on. Also, let's say we drop Visual 9, still doesn't help us much because the Visual 10 and 11 still don't support C++11 that much. Basic feature like initializer lists or other required list, Visual 13. So dropping just the oldest compiler doesn't help a lot with this. So we would have to switch to a way more recent compiler for C++11. And honestly, I have no idea what most banks and quants use. And from I tried some informal poll again, but I didn't have a lot of answers, and they were distributed. So we'll see. So what this means is probably we're not going to switch to C++11 for the official distribution any soon. In the meantime, we are keeping ready, meaning that again, if you look at the Travis, our build metrics on Travis, you might see that in the flags we are passing to the command. It's the one in the bottom part of the slide, the one highlighted in what should be green. I'm not sure what you see on this screen, but anyway, we are passing standard equals ++14. That's for one run. Others have C++11, or anyway, we are checking routinely that if you compile QuantLib under C++11 and 14, it works anyway. So there are no constructs which are incompatible with that. One thing we are doing though is we are muting. Well, I told you we are treating warnings as error. We don't want them. We are muting deprecation warnings. Any of you can guess why? No, it's auto pointer, which we are using in the library, and it was deprecated in C++11. It's going to be removed in C++17, which was recently approved. Which means that if any compiler starts using C++17 as default mode of compilation, we're going to have to do something for this. Already, if you compile under Ubuntu, under a recent Ubuntu, with the standard, the default settings, you get lots of warning, which I don't like really. I would like compilation to go on without warnings, which means we might start doing something to, well, under Linux we can use configure and detect what happens if the compiler supports auto pointer or not, and switch to, well, I don't know, maybe unique pointer or some kind of boost pointer, we'll see. Well, anyway, we'll have to start moving in this direction and start modernizing some features conditionally. Which, well, I guess the question is, where do we go from here? How we start moving in some direction? Well, one way we can do it is we might encourage people like Unger, who picked up my Slack while I was just thinking about it and not doing anything. So he forked the library and modernized it, meaning that he replaced all the boost features with features now in the standard library. He used the C++17 as mode of compilation, replaced the old auto tools with CMake, replaced the boost test tools with Catch, which is a more modern test framework. And from what I've seen, he didn't use a lot of new language features. Mostly he replaced bind with lambdas, which are now available in the language there, and are much more readable in my opinion than bind. But there's not a lot of new language features used in his fork. We might pick some of these changes at some point. We have to be kind of careful though, because some of the things, we're not going to do any big change, I think, because some of those changes turn out to be a big risky. For instance, one was switching boost shared pointer for a stud shared pointer. Now it's in the standard library. There is a difference though between the two implementations. Boost shared pointer can check and well, in our configuration does check for access, meaning that if like if you access some method from a shared pointer and the shared pointer is empty, basically what I'm doing here in this sample code, what you get is an exception. Okay, the access check the access inside the shared pointer, checks for a null pointer, raises an exception, you catch it. Stud pointer, for efficiency, because you don't pay for what you don't use, doesn't. So what you get in this case is not an exception that you can catch, it's just a segmentation fault. Which, I mean, stud shared pointer is right to do this, because if you are using a shared pointer in a function and you call 5 methods from that function, you shouldn't check 5 times. It's a waste. You just check once at the beginning explicitly, and then you just use the pointer. So that it's correct, but it's just that we made the mistake of relying on the booster behavior. And so if we wanted to switch now to stud shared pointer, since I wouldn't release like this, because segmentation fault is inconvenient in C++ and outright unacceptable in Python, where we export QuantLib, we would have to go in and add the checks which are missing. Of course, that's impossible to do manually. We'd have to. It's probably possible to do with some kind of static analysis tool. There are tools in Clang and in other tools that can warn you of possibly null access to a pointer, so you can go and add the checks where they are needed. So there's work to do. And also we have the non-trivial matter of, let's say we want to move in some way to C++11. how we actually doing, remembering our constraint. There are a few questions about this. The first being, how much effort can we put into this, and what's the return on this investment? Because I'm a developer too, new stuff is cool, it would be nice to write into C++11, but we have fiddle faddle that works right now, and unless there is some big advantage, big return, I'm not sure if it's worth moving to the. We should carefully weight the return on the effort and see if it's worth doing it. Also because if we also start, if we're probably not switching to C++11 outright. Do we do a parallel code base? If so, we do parallel releases with double the maintenance effort, or we just keep releasing officially just the usual old style version, with the risk that most people don't use the new stuff, and so the effort is wasted. We have to think about it. Another question: which language version should we support? C++11, so that we have most of the features but not all, and maybe more compilers support it and more people can jump on the wagon, or C++17, so we have all the new features. And again, we have to evaluate the effort and the return. And the third question, which I'm thinking it's more and more important these days, can we integrate continuously with the master branch? Because if we can't keep merging from master to this new branch, and we let the two branches diverge, we are going to be in deep fiddle faddle somewhere along the line. And because we are not going to be able to reconcile it. I'm trying to see if Travis, for instance, can do it. So if you can have a branch that automatically merges the latest changes from master and rebuild the C++11 branch or 17 branch in that case. So lots of questions. You've heard me list lots of reasons why we probably shouldn't do it, which is why, well, I was thinking of trying it in this coming year, well, as an experiment mostly. So I might start a new branch on GitHub where we start doing some of this development. I'll see if I can set up continuous integration and start doing something. No promises, as I said. An experiment might be that after a few months I say, nah, it's not worth it, or it doesn't work, and we just drop it. Well, in any case, it will probably give me something to write about, so I'll try to report on what happens on my blog, and well, we'll see what happens. And well, thanks for now.